An object of mass 5 kilograms is thrown downwards with an initial speed of 50 meters per second. The force due to air resistance has a magnitude of 10 v, where v is the object's speed in meters per second. If the object is initially 500 meters above the ground, determine when it will strike the ground. First, we should draw a picture. As we draw it, we need to make some decisions. If we draw our object as a rectangle, then the rectangle has two forces acting on it. The force due to gravity, which acts down, and the force due to air resistance, Fd, which acts opposite the object's motion. So in this problem, since the object is going down, the air resistance must act up. We also get to choose which direction we want to be the positive direction and at what height we want to be height 0. You can do whatever you want as long as you're clear and consistent. I'm going to make down the positive direction because I like to make the direction of motion the positive direction whenever I can, and I'll choose height x equals 0 to be the initial height of the object. Since the object starts 500 meters above the ground, that makes the ground x equals 500. Because I've chosen to make down the positive direction, this means that since the object is thrown downwards with an initial speed of 50 meters per second, x prime of 0, which is the velocity at time 0, is going to be positive 50. And since gravity acts down, Fg is going to be positive mg. Now here's the tricky part. I need to write an equation that says the sum of the forces acting on the object is the mass times the acceleration, which I typically write as ma equals the sum of the forces. In this problem, ma equals the force due to gravity plus the force due to air resistance. We know that Fg is mg, so we just need an expression for F sub d. We know the magnitude is 10 times the speed, but should Fd equal positive 10v or negative 10v? Here's the most important thing to remember. Since air resistance is proportional to speed, your choice of coordinate system has no impact on the expression for F sub d. We have to choose F sub d equals negative 10v to guarantee that the force due to air resistance acts opposite the direction of motion, which is given by the sign of v. Whatever the sign of the velocity is, the negative in negative 10v guarantees that the sign of Fd will be the opposite. Now that we have ma equals mg minus 10v, we can see that we only have acceleration and velocity, no position in our equation. So it makes the most sense to replace a with v prime, giving us the initial value problem mv prime equals mg minus 10v, where v of 0 equals 50. And since we know the mass of the object is 5 kilograms, we can replace m with 5 and rewrite this as 5v prime equals 5g minus 10, which we can simplify by dividing the equation through by 5. This is a separable differential equation, but also first-order linear non-homogeneous, so I'm going to solve it by separation of variables. And just to save myself a little writing, we've established that velocity is a vector, so I'm going to stop using a vector symbol with it. By now, you're familiar with solving separable equations, so I'm just going to write down the steps. I encourage you to pause the video, try solving the equation on your own, and then press play to check with my answer. The general solution is v equals g over 2 plus b e to the negative 2t, or approximately 4.9 plus b e to the negative 2t. Now we can apply the initial condition. 50 equals 4.9 plus b e to the 0. So b is 45.1, making our velocity 4.9 plus 45.1 e to the negative 2t. Notice that our velocity function is a decreasing function that is always positive. The always positive part makes sense because our object is always moving downward, which is what I chose as the positive direction. The fact that the velocity decreases indicates a strong drag force. The object is slowing down as it falls, so perhaps some sort of parachute is involved. But we aren't done yet. The problem asks when the object hits the ground. That's a question related to position, not velocity. Since we know that velocity is the derivative of position, we can write that x prime equals 4.9 plus 45.1 e to the negative 2t, and then integrate to find the position function. Again, I encourage you to try the integral on your own before checking with my answer. So you should have gotten that x is 4.9t minus 22.5 e to the negative 2t plus c. Now we can apply that I defined the initial position of the object to be x equals 0 and solve for c, which gives us that c has to be 22.55. So x of t is 4.9t minus 22.5 e to the negative 2t plus 22.55. Now to finish the problem, we need to find when the object hits the ground, which in my coordinate system amounts to solving for when x equals 500. Go ahead and stare at that equation for a while and think about how you would solve it. You can press pause and I'll wait. I hope you didn't spend too much time trying because the equation cannot be solved algebraically. This happens because of the mix of the polynomial function with the exponential function. Our choices are either using technology or approximating. I'd argue that approximating is much faster and just as accurate in this situation. Go ahead and guess how long you think it takes the object to hit the ground, remembering that t is measured in seconds. Then, whatever your guess is, use a calculator to evaluate what 22.55 e to the negative 2t is using your guess as t. What happens? You should get a really small value. If I guess about 10 seconds to fall, then 22.55 times e to the negative 20 is approximately 0.0000005. That's small, too small to matter. So the exponential term in our equation is negligible even for modestly large values of t. So we can just approximate that x is 4.9t plus 22.55 and then solve 500 equals 4.9t plus 22.55 instead, which is much easier. Solving that equation gives that t is approximately 97.4. So it takes about 97 seconds for the object to hit the ground. Remember, the time to fall is so large because the drag force was so strong, indicating some sort of parachute or something. Now, to convince you that this approximation method was really just as good as using technology, I'm going to go to wolframalpha.com and have it solve the original equation 500 equals 4.9t plus 22.55 e to the negative 2t plus 22.55. It says that t is approximately 97.4388, which is basically the same answer we got, especially when you consider that I used a rounded value of 9.8 for the acceleration due to gravity g.